Right. Today we are going to be looking specifically at parallel and perpendicular lines. That's also what we're going to be looking at on Thursday/Friday of this week. It's the second hour right now. Okay. So parallel lines are two lines that are never going to cross each other. So we've got two parallel lines here. Parallel lines have the same slope. Their slopes are exactly equal. So if the slope of one line is 2, the slope of the other line is 2. Negative 3/4, negative 3/4. So parallel lines have the exact same slope. And because they have the same slope, they'll be moving at the same rate, and they'll never catch each other. Perpendicular lines are two lines that cross each other at a 90-degree angle, like a plus sign or like an X, whichever way you're angled. So perpendicular lines cross themselves at a 90-degree angle, and their slopes are opposite reciprocals. So what opposite means is it's the opposite sign. If one was positive, the other one's negative. One was negative, the other one's positive. And then reciprocals are flipped fractions. So like 1/4 and 4/1, 2/3 and 3/2. So you take the fraction, you flip it, and you make it the opposite sign. So the first thing that we're going to do today is we are going to practice finding slopes that are parallel and slopes that are perpendicular. So finding slopes that are parallel is easy because a slope that is parallel is the exact same thing. So a slope that's parallel to 5 is also going to be 5. A slope that's parallel to 3/4 is also going to be 3/4. A slope that's parallel to negative 1/2 is negative 1/2. A slope that's parallel to 0 is 0. And a slope that's parallel to negative 1 is negative 1. So slopes that are parallel are the exact same. Okay, slopes that are perpendicular, we've got to do a little bit more work for. So it is the opposite reciprocal. So we have to take the sign. If it was positive, it becomes negative. If it was negative, it becomes positive. And we also have to flip it. So if it's not a fraction, just like we've been able to do all unit, we can put it over 1. So I'm going to go ahead and put this 5/1. And a slope that is perpendicular to 5/1 would be negative 1/5. So you take it, you flip it upside down, and you make it negative if it was positive. Okay, perpendicular to 3/4. It's currently positive, so I'm going to make it negative, and I'm going to flip that. It's going to be 4/3. Okay, the next one, negative 1/2. We're going to flip that. And since it's negative, we make it positive. It's always the opposite sign. So it's going to become positive 2/1. And if we wanted to just write 2, we could. We don't need the over 1. So 2/1 and 2 would both be correct. Okay, this next one is kind of a trickish question. If I have a slope that's 0, what is going to be perpendicular to a slope of 0? Undefined. Let's talk about how we would get that. If a slope is not a fraction, I can put it over 1. And then I would flip this. I would end up with negative 1/0. Am I allowed to divide by 0? No. So I made it negative, I flipped it, so this would just become an undefined slope. So if you see 0 and undefined, they're always the reciprocals of each other. Okay, and then the last one here, -1, we're going to put that over 1 to be able to flip it. But when we flip it, it's still just 1 over 1. It also becomes positive because it's currently negative. Okay, so with the exception of the 0 and undefined, which is a little weird, for the rest of them, if your slope was positive, your perpendicular slope's negative. If your slope was negative, your perpendicular slope's positive. And you just take that fraction and you flip it upside down. Any questions right now? Okay, so go ahead and flip this over. Let's look at the types of problems that you guys are going to be doing on today's assignment. So, it says, write an equation for the line that is parallel to y equals 3x plus 2 and has a y-intercept at 0, -1, then graph both lines. So we are going to have to find the slope of a parallel line, the new y-intercept, which we just give you, and then we write an equation, and then we graph both of the lines. So for this first one, it's asking for an equation that is parallel. Parallel means the same slope. What is the slope of this line right now?
3x.
Just the 3. So our slope currently is just that 3. So if it's a parallel line, we want to have the same slope. So our slope of our new line is also going to be 3. And then we tell you that the y-intercept is at 0, -1. So my y-intercept is at -1. And then from there, we're just going to put that together into an equation. So y equals mx plus b is going to be y equals 3x minus 1. Okay. Any questions about writing the equation? On the first 4 on your assignment, I just have you write the equation because I didn't have enough space to have you write and graph all of them, and I wanted more examples. So I think on the first 4, that's all you have to do. Then we are going to graph both lines. I am going to graph the first line first, so y equals 3x plus 2. So I'm going to start at a y-intercept of 2. And then I'm going to graph a slope of 3. So I go up 3, right 1. I cannot go any further that direction, so I'm going to go the opposite way. I'm going to go down 3, left 1 a couple times. I want to make that line go all the way across my graph. We'll connect all of those. What's up, Cass? Yeah. So connect all of those. Okay? And then we are graphing both lines. So that was the original line, the 3x plus 2. We are also going to graph our new line. So our new line is 3x minus 1. Thank you. Grab a note sheet, please. There we go. So we'll start at -1. I'm doing this one in red. And we'll graph a slope of 3 as well. So I'll go up 3, right 1. Up 3, right 1. And we can also go down 3, left 1. Down 3, left 1. Connect all of those. Okay. If 2 lines are parallel, they should never cross. So if you've successfully written your equations and graphed them, those 2 lines should never cross. Okay. Any questions about either of those? Okay, I'm going to pause this and ask a question. Just making sure. Okay, so we've got one more example. The next example, pay attention as you're going through, because it's one word difference. Write an equation for the line that is perpendicular to y equals 2/3 x minus 1, and has a y-intercept at 0, 4, then graph both lines again. So for this one, we need a perpendicular slope. So that's what we did on the front of here, is we practiced finding perpendicular slopes. If my current slope is 2/3, perpendicular to that, I flip it and I make it negative. So my new slope is going to be -3/2. And I've got a y-intercept at 4. So that makes my equation y equals -3/2 x plus 4. So pay attention to whether it's asking you to do a parallel line or a perpendicular line, because that's going to be a huge difference. Okay, we'll graph these, look and analyze the fact that they are perpendicular, and that's it. So for this one, we're going to graph y equals 2/3 x minus 1 first. So we'll start at -1. We're going to graph a slope of 2/3. So we'll go up 2, right 3, as many times as we can. And since I don't know where they're going to cross, I should go down to left 3 as well. I would connect those points, especially on the perpendicular ones, before I move on to the next line, because otherwise I might get my points confused as to which line they are for. Okay. Then from there, I'm going to graph the other line. So I've got an equation for it that I just wrote. I start at a y-intercept of +4. And my slope is -3/2. So I go down 3, right 2, down 3, right 2, down 3, right 2. And connect those. And you should be able to know that you got at least the slopes right if when you look at it, you could fit either another sheet of paper or your ruler or something right here in this corner. See how that fits perfectly? It's a perfect right angle. Okay, any questions right now? Okay, groovy. I'm going to stop my video then.